Assalamualaikum everyone and a very good day to all. Today I'm going to share with you the overview of data communications, its components, data representation and data flow. Here is the table of contents for you to navigate through this video. These are the learning objectives to be obtained after you went through this video. You can check them yourself whether you have acquired the objectives or not. We want to understand what is data communications. Data communication is the exchange of data between two devices via some form of transmission media. We will also learn about different components within data communication, the types of data exchange, and also the different types of data representation and the flow of data. So to understand it further, communicating through share of information, it means that we are sharing information, and this can be done either locally or remotely. Locally means face-to-face, i.e. when you come to the class and we have face-to-face class, and now we are doing remote communication. And in other word, remote communication is also known as telecommunication, which means communication at a distance. This includes telephony, telegraph, and television. So tele is actually Greek for far, so it means that far communication. Data communication means that communicating devices must be part of that communicating system. So this communication system must be part of combination of hardware, that is physical equipment, and also software, which means the program. The effectiveness of this communicating or communication system, it depends on three fundamental effective characteristics, that is delivery, accuracy, and timeliness. Delivery means that the system must deliver data to the correct destination. If it doesn't, that means that the delivery is failed. And accuracy means that the delivery must be accurate, meaning with no discrepancies or mistakes or errors. If there's errors, even the smallest mistake in a very sensitive transaction, for example, bank transaction, 100 can be changed to 1000 with just one added value or number at the end. So accuracy is very important. Timeliness is important, especially if you are dealing with real-time transmission such as video or even audio, where this delivery has to be done in timely manner. If it doesn't, then it will relay nonsense. Like for example, if the video arrive at a different time than the audio, then you cannot make sense of what the information that has been shared. There are 5 different components in a data communication systems. We have sender, which is the device that sends the data message, such as workstation or handphone. We have receiver, which is the device that receives the message. Again, it can be a workstation, a telephone, or television. And then we have a protocol. Protocol is the set of rules that governs data communications. It is basically the rules or the agreement between the communicating devices. Without these rules or protocol, the two devices may be connected but not communicating. We can say, like for example, chicken and duck. Okay, they can be communicating but they might not understand each other because they're talking different languages. Or maybe between French, a guy who's talking French and another guy speaking Malay. We are talking at the same time but we are not communicating because we do not understand. We do not have a mutual agreement, understanding, or protocol between each other, which is in this case a language. And then we have a message. Okay, message is the information or data to be communicated, and it can be represented with different type of representation, which we will look at in the next slide. Before that, let's look at this animation where a sender and receiver both have protocols, and there are mediums in between, and the messages went through the medium from sender to receiver. Message is the information that comes in any or combination of text, numbers, images, audio, and video. In text, numbers, and images, they are represented as a bit pattern. Okay, there are different mechanisms for each of these representation, but basically they are code to represent symbols, and this type of process is called coding. With images, the different mechanism basically means that they are divided into matrix of pixels, and this matrix of pixels is the resolution of the images. With better representation of the image, meaning better resolution, so there will be more pixels within the matrices. So more memory will be needed. And in terms of audio, it is by nature is different than text, number, or image or images, and it is continuous. It is not discrete. So video can be produced either as a continuous form or it can be a combination of images. With this, they are temporal instead of spatial. We have a motion of time, and this is what we have as a video. Next, we go to the direction of data flows. Communication between two devices can either be simplex or half duplex or full duplex. In simplex mode, the communication is unidirectional. In this example, you can see it is moving from right to left. Okay, these binary codes are moving unidirectional, as in like a one-way street, meaning that between the two devices only one link can transmit and the other can receive. One example is between keyboard and a CPU or a monitor. Okay, the keyboard can only introduce input and the monitor can only accept output. Example for half duplex mode is a walkie-talkie where each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. You can imagine the half duplex mode is like a one-lane road with two directional traffic, especially when you have a small road where only one car can use the road, so the other one or the other side has to wait while one of the car is using the lane or the road or the small road. Okay, and then we have a full duplex. Full duplex means both stations can transmit and receive simultaneously, and the example is your phone or the Galaxy X. Alright. The full duplex can have the analogy like the two-way street with traffic flowing in both directions at the same time. So the signal is going to either direction, share the capacity of the link, and but the link must contain two physically separate transmission paths, one for sending and the other for receiving. As you can see for the example at the very bottom here, okay, one is moving from right to left and the other is from left to right. All right. This is another figure for you to understand in terms of simplex, the direction of the data is unidirectional, whereas for half duplex, it is it can be moved from both ways. It can be bidirectional, but not at the same time, whereas for full duplex, direction of all data at all time can be simultaneously both ways. Before I end this video, please let me know how is your understanding on this topic throughout this video so far at this link. Your participation is highly appreciated. If you have any questions or comments, please let me know. Thank you and see you on the next video.